Hi, my name is Yakir. I'll introduce you with a project I made during my Java course. The goal of this project is to mimic the memory management unit and then allowing us to run through the processes that was made by the MMU using the Java GUI. The system architecture is as follows. Using the CLI we are able to enter our desired caching algorithm and the RAM capacity. Once we did that, the MMU will perform the job using the selected caching algorithm, and each step that was made will be written to a log file. Once the log file was created, the Java GUI window will open and allow us to run through the log file and perform each step that was made by the MMU. The MMU architecture is as follows. The MMU will get the pages that were requested by the operating system from the hard disk or the RAM memory. Depends on the caching algorithm. The MMU currently has 3 caching algorithms, which are LRU, MFU, and second chance, and they are transparent to the MMU since it's using them using the iAlgoCache interface. I'll introduce a few main classes that were created in the project. The second chance algorithm cache implementation implements the iAlgoCache interface. Its API works with a list of elements. The getElement method touches the element if they exist, and if they do not exist in the cache, it will do nothing. The put element will add the pages to the RAM using the second chance algorithm. The remove element will clear the pages from the cache. The memory management unit class gets the RAM capacity and the caching algorithm to work with. The main job of this class is performed by the getPages method. Its job is to perform the page faults and page replacements as needed, and eventually to return the required pages to the user. If the RAM is not full yet, it will perform a page fault. If it is full, it will perform a page replacement. In addition, this method is synchronized, so when multiple threads will try to use it, only the current one could. The process class implements the runnable interface, so it could run in threads. That's the class that will operate the MMU and will do so in cycles. It will fill the data for each page. The data is configured in the process cycle. Each process has a time slice to work at, and in order to simulate a real working process, it will sleep for a given period of time. The MMU model is part of the MVC architecture, and its job is to start the system. It will create the MMU instance and relevant caching algorithm. It will read the configuration that is given to the system from a JSON file. It will create the processes. It will execute the algorithm for the current configuration and write each step to the log file. Once the execution is done, it will notify the controller that the log file was created, and the controller will keep working from there. The classes that are part of the MVC are the MMU model, which performs the data processing the system, the MMU view, which is responsible for the GUI data of the system, viewing the relevant data in the selected way of the view, and the MMU controller, which is responsible to perform the link between the model and the view. Using the controller, we are able to change the view entirely without changing the system way of work. I check the system using a GUnit that checks the relevant functionality. Here I check the functionality of the caching algorithm. I check the LRU algorithm, the MFU algorithm, and the second chance algorithm. In both cases, I did that using specific values and verify that the returned values are correct. Now I'll demonstrate the system workflow. The workflow begins with the JSON file. The JSON file stores data regarding each process in the system. Each process has several process cycles and specific data. Once we have the JSON file and we run the system, we will be prompted with the CLI. In the CLI, we will hit the start so we can start the system, and then we will be asked to enter a specific caching algorithm and RAM capacity. Let's say second chance with RAM capacity of 15. We hit the enter, we let the system run, and then we will get the Java window. In the Java window, we will be able to see the RAM table, the processes that run in the system, the play and play all buttons, the counters for the page fault and page replacement that occurred during the caching algorithm, and the current command that we will play from the log file. If we hit the play button, we will see that the first command we played was page fault, and the counter increased in 1. If we keep hitting the play button, we will see how the RAM table starts to fill from each process. Now, if we press the play all button, all the commands will be played and we will get the final outcome. In any given moment, we will be able to filter and see what process was responsible for what pages. For example, if I press the process 0, I see that the process 0 at the end was responsible for page 4 and page 3. If I pick a few, I'll see which pages were under this process's responsibility. And this is the system. The final outcome says that this is how the RAM table will look. The page fault amount is 15, the page replacement amount is 10, and the final command that was played was get pages, process number 2, page number 8, and that it's the data it contained.